about 5G core network use case study presented by Mohammed Fazil Salimi, which is a 5G core architect at Rakuten Mobile in Japan. So we are very glad to have you here with us, Mohammed. Thank you again for accepting the invitation and sharing your precious knowledge with us. Just before starting, I would like to say some words about our initiative, which is a community we have started some weeks before, and the initiative is about building a community around technologies in telecom and IT industries, with an objective to connecting professionals working in IT and telecom. So mainly we are from the Telecom Institute of Oran, Nigeria. We are working in Algeria and abroad. So the main objective is connecting people, sharing your knowledge, experience, and our passion. So the objective is to make it a tradition with more commitment and involvement, with more events, workshops we will organize in the future. So this is what I wanted to say. So I'm handing over to you, Mohammed Fazil, to start your presentation. And again, thank you a lot for your time and for accepting the invitation.
Thank you very much, Mohammed. Hello, everyone, and good night or evening or morning to all of you. I hope all of you are fine and safe during this coronavirus situation. I am Mohammed Fazil Salimi from Rakuten Mobile as the core architect, actually 5G core architect. So today, this topic is selected to be share my screen with you. Can you see my screen?
Yeah, perfect.
Very good. Okay, today we want to study together about the 5G and 5G use cases. So let's go to the topics. For today, we have 4 topics. The first one would be about the path to the containerized network functions and also virtualization. In this topic, we would say that why Rakuten Mobile is called as the first end-to-end cloud native network. The next one is the path to the final 5G implementation. There are many questions about how to implement and deploy 5G network. What should be happen to the 4G? So what is the relation between these two technologies? So we will discuss in this topic. And the next one is more important feature in the 5G. We call it network slicing. We will discuss about the network slice, how they works, and what is the requirement for network slicing. And after that, we will discuss about the multi-access edge computing, which is one of the hot topics that we can see every operator is working on that. So let's go to the just one prerequisite. I want to sync up with all of you about the 5G network because tonight we just referred to this shape. So I just wanted to bring one simple network architecture for the 5G. You can see UE, radio. So in the 4G, we had MME for both session management and mobility management. But here in 5G, we have AMF as the access and mobility function or access management function. So just access management and mobility management will be managed by the AMF. We have SMF that include, I can say, session management part of the MME and also session management part of the SGW and PGW. It is somehow same as the CUPS architecture that we had in 4G as well. So we have UPF. This UPF acts as the user plane part of SGW and PGW. We can have multiple UPF in our network according to the design. So in 4G we had HSS, but 5G It is divided to AUSF and UDM. AUSF will manage the authentication part, and also UDM will manage the subscription part. We have PCF, what we call it in the 4G as PCRF. Also, we have CHF as the charging part in the 5G as well. So if time is fine with you all, let's the first one is about the path to the containerized network function and virtualization. We want to show that why this is so much important in case of time to market decrement, and also in case of decreasing the capex and opex cost in the network. Okay, let's have it history review of telecom implementation. As most of you know, we had physical solutions at first that vendor will provide all the functionalities as part of this physical solution, including the vendor hardware, OS, and also the services. The OS was customized for just related service, and also the hardware was used for this service. So after end of life for this software, uh, the hardware was not so much useful, so it was a wasted resource. Because of that, in the next era, we have original NFV to use COT servers as the hardware instead of using vendor hardware. That decreased the capex investment. Sorry, one of the microphone is on, I think. So it decreased the capex cost and investments. It was very good. And so in this case, the maintenance of this COTS hardware was more easier for the IT man. And also I can say that after the using of this service, we can use that COTS server for another services. On top of the COTS, we had VM and virtualization. And the next era is the container-based era that we use container on top of the COTS hardware. It was so much useful more than the VM. I will explain this part. And as the end part, we have cloud native. Thanks to Cloud Native Foundation, they just selected container-based solution and also microservice software architecture to bring this kind of solution that we discuss it in detail. So in next step, I would prefer to just have a comparison between the NFV solution and container solution. As most of you know, in the NFV solution, we had the hardware. We should install our host OS on top of all the hardwares. So we will have hypervisor for cloudification and virtualization of our resources. So we have some kind of virtual resources. On top of that, hypervisor used these resources to install the VMs. Each VM needs to have guest OS, dedicated guest OS, I can say, related to the application that we want to run in the VM. But in the container-based solution, on top of the hardware and host OS, instead of the hypervisor, we have container runtime. We can call it Docker engine as one of the successful technologies in container. So what Docker do for us is to relate all the applications and containers to the host OS kernel, I can say, and hardware directly without using the guest OS. So it has two benefits for us. First of that, we do not need to install any guest OS on the container solution. So it would reduce the resource utilization in case of using OS. And also when you want to run one container, and there is no guest OS to be run, same as Linux OS. So it is more faster than the VM. So this is the reason that Cloud Native selected container instead of the VM for Cloud Native solutions. Another topic that I prefer to discuss with you is about the microservice architecture. You know, traditionally we had monolithic architecture. In this one service had some kind of, for example, number of service modules. These service module were dependent together, so you had to develop all of these service modules, integrate together, and after that test your solution. But it was so much time consuming for just building one simple software, and it was a huge long time for time to market. So after that we had the microservice architecture. In this one service can be divided to simple microservices that they are independent from the other. So you will have separated developer team to develop each microservice, and after that integrate to them. It is very good. Assume that instead of having one AMF and let me just use 4G aspects, in case of having one MME and develop all parts together, you can divide it to some kind of microservices and just develop one by one, and at the end integrate it together. So it was another option that's selected by Cloud Native Foundation. So now I think we know what is the Cloud Native solution and what are the main aspects in Cloud Native. So let me have a detailed discussion about the container at first, because we need this kind of information to go through. Okay, as I mentioned, the Docker is responsible to build the container, ship, and run them into the solution. Each container should be just one simple software, for example, one web server, I can say Nginx, for example. But the case is that for such a telco grade solutions, we will have many and much number of containers. So it was somehow hard for the Docker to manage all of these containers. So we need one container orchestrator to manage all of the containers. And the best solution for this case is the Kubernetes. So Kubernetes will come and just define Kubernetes cluster. It's up to you to how to design your clusters according to network. For example, for the radio, you can have one Kubernetes cluster, and for the core, you can have another one cluster and just integrate to them. In this cluster, you can see some kind of nodes, master node and worker node. But what is the node? The node is the resources that you want to use exactly. It can be directly COT server, for example, just simple Dell server, HP server. We call this solution as bare metal, or you can use your VM as the node. So we call it nested VM. I mean, you can run your container on top of the VMs as well. We call it nested VM. There are some kind of differences. It's up to the operator and designer how to select the node type. It would be bare metal or nested VM. Okay, by the way, we can see that there is two type of node, master and worker. Worker node is when and where we host the containers there. So Kubernetes define pods as the microservice. Okay, so each pod can include the number of containers, and these containers are just running for a same service, or I can call it microservice. So the target is same for all the containers in one pod. Some kind of resources, same as the database or networking, would be shared between these containers. And also, of course, we need one master node to manage all the worker nodes and pods. For example, to distribute the pods on multiple worker node in case of the redundancy, or in case of any failure to provide another pod on top of that. Yeah, this is what we call it master node. But we can see just Docker in the worker node in order to build and run the container that is included in each pod. Very good. So let's have a 5G network over container together. So for this case, I just used core network aspects, AMF, SMF, and UPF. You can see multiple number of pods for each one, for AMF, SMF, and UDF. So it is very good. You have 3 AMF or AMF instance, I can call it. At the same time, for example, if you lose one of the AMF, you have another AMF pods that they worked fine. And yeah, this is container based, everything is fine, you can use virtualization. But the case is that AMF is a how to say big software that we can have, okay, same as the MME, that we can find it in legacy platform as just one big node. It could include 1 rack or 2 racks of servers. So because of that, cloud native uses microservices in the 5G as well. So in this case, for example, AMF can be divided to multiple microservices, NGAP proxy to communicate with the 5G radio, HTTP proxy to communicate with other SPI network functions, same as SMF, UDM, PCF, and mobility management services and session management services. So why we should use this kind of microservice architecture? Because each pod just include a minimum number of resources, because this is just what we want to bring as the microservice. For example, NGAP proxy. In this case, if just we fail one of NGAP proxy, so just minimum number of resources will goes down, and it would be easy to reserve another resources and bring another pod online in our network. And also, if we want to just develop or change some of the features. For example, we want to have a change in mobility management in our network. We do not need to freeze one AMF completely. We can just freeze one of our mobility management service pods. So other D pods will work fine, and there is no impact to the service and operation. And it would be so much easier for maintenance and developing the solution. But what should be the question? Now you can see many number of pods. For example, we have NGAP pod that is working with 5G radio. So assume that the request of subscriber for attaching and registering to network came to one of the NGAP pods. So we have many other mobility management pod or session management pod. How the source pod should select the target pod? This is what is so much hard that we can implement in Kubernetes. So there is another solution, we call it Istio or service mesh. Istio is one of the best technologies in the service mesh to just connect all the pods together and manage them. Now, what Istio do exactly is that Istio just inject one sidecar container in each pod. We call it envoy. Okay, so the envoy is responsible for the forwarding of the packet to another pod. Okay, so as the data plane, we can see just some of the pods are connected together, and in the control plane of the Istio, we can have some kind of module that allows each envoy how to terminate or forward the traffic to the next pod, how to manage the received traffic, and also can just manage the KPI and other aspects of network we need. So as the service mesh ecosystem, what we designed, it was just how to manage the traffic. But you know, for having one 5G system, for example, we need some kind of aspects that, as an example, I provided some of them in this slide, okay? So in the right hand, you can see Prometheus and Grafana that they are connected to the Istio. So all the KPIs would be fetched to the Prometheus and will be somehow processed and will be ready to show to the customer or even to the operation team. But we use just Grafana to visualize this kind of information and provide KPI dashboards. This kind of dashboard and KPIs could be system KPI, I can say, for example, CPU utilization, the RAM, the utilization of each pod, for example, and also service KPI, for example, the number of registered subscriber or registration um, successfully ratio. In the left hand, there is another requirement in the operator, that is tracing. Okay, we have to trace one of the subscriber, for example, to troubleshoot some issues. We are using Jaeger, and this Jaeger just install Jaeger proxy or client on each pod. And after that, all the parameters and related traces would be sent to the Jaeger server. So we will have all the traces, even for just one subscriber or all the subscriber in Jaeger server. And in order to visualize this kind of traces, same as what we had before, we use Piali. Okay, just as a hint for you guys, I added this slide as well. According to 3GPP release 16, we have another node. We call it SCP, Service Communication Proxy. This SCP acts same as the DRA in 4G or STP in the 3G to manage and distribute related traffic to the target network functions. In the 4G, diameter protocol would be handled by DRA, for example. In the 5G, the HTTP protocol would be handled by service communication proxy. Why I added this slide is that this service communication proxy acts same as the envoy. So this is not freezed yet in the 3GPP release 16 about the SCP. This is an open item, but I can see most of the vendors are working in SCP because it is somehow telecom natural, uh, more than the envoy, SCP, envoy, Istio aspects that are somehow IT aspects. So yeah, this is just, we call it SCP. We can use it in our network to just get the traffic from all the nodes, network functions, and forward them to the target network functions. Okay, all of this information was gathered to say that, okay, why we call Rakuten Mobile as the first end-to-end cloud native network is that after the radio, in case of 4G or 5G, we have all the thing on the CNF network. So and just packet goes through the internet by virtualized resources, and it could decrease the cost of maintenance and also OPEX. So I can say that the end price to the customer should be decreased dramatically. Okay, it was all from my side for the first part. If you have any question, do not hesitate to just mention in the chat box. I believe after my presentation, we can go through them and discuss together. Okay, and the next topic is the path to the final 5G implementation. Of course, most of the operator, when 5G came in, they were concerned how to deploy their network, what would be happen to the 4G network, how to implement 5G and interact it to the 4G. So because of that, GSMA provides some kind of options for the 5G implementation beside the 4G. We call them SA or NSA. SA means a standalone, that we can see here in option 2. In this standalone, we have a 5G solution completely, including the NR and 5G core as well. But non-standalone options are a mix of 4G and 5G solution that we will go through them. Okay, the first option is the pure simple 4G that we have in most of current operator actually. Another one, as I mentioned, is the option 2. So in the option 2, we have just 5G network that is separated down from the 4G network. The next option is option 5. In option 5, we can say that operator should just deploy the 5G core. Maybe it would be easier than to have many radio, 5G radio, I mean, at the first of the launch. So you can just go through LTE radio to the 5G, of course, consider LTE network capable UE, for example, dual connectivity should be supported. Each option needs dedicated features in the UE. So whenever you want to choose one of these options, you have to take care about the UE capability that you have in your market as well. Next one that is so much easier and capable one is to, instead of just deploying 5GC, use your EPC and install and set up your 5G NR 5G radio and just connect it to the EPC. I can say that the connection between NR and EPC is just GTPU connectivity. So just user plane go through the EPC, and signaling of radio to the EPC would be carried by current LTE network. So you have to consider that whenever you want to install one NR, you should have LTE coverage as well. This is one of the main concerns that you have to take care about that. And the next one is option 4. In the option 4, we will have 5GC as the core instead of EPC, and both LTE and NR would be connected to 5G core, and the signaling of LTE 4G radio would be carried to the 5GC by the 5G new radio. And in the option 7, that is more complicated than option 4, we have 5G core instead of the EPC, and also we have NR that is connected to 5G core as well. Okay, what is the actual choices that we can use in our network and the path to have complete 5G in our network? As you can see in the left hand, this is ENDC option 3X that we can use in our network. So in this case, UE should be capable for dual connectivity to connect it at the same time to LTE radio and NR radio. And it would attach to the 4G network at first, and after that sense 5G coverage. Whenever there is 5G coverage, you ask LTE to hand over to the 5G coverage. So this 5G new radio would be the termination point of the user plane to the subscriber and UE. Yeah. Also, at the middle of this shape, you can see VCU. This is what we call it, cloud RAN. Okay. So the most part of the physical radio should be the antenna and RRU. After that, BBU is visualized, and in this solution, BBU would be same between the LTE and NR radio as well. So after providing this option 3X on top of the 4G that we will have, let's just implement our 5G completely by option 2. So in case of option 2, you will have your 5GC beside your EPC. So I can say that this is the mix of EPC and 5GC, option 1 and option 2 together. So what would be the handover in this case? How subscriber would hand over between the EPC and 5GC. So in this case, we will have new interface, N26 interface that use control plane as how to say GTPC. So whenever subscriber want to just hand over between 5G and 4G, this interface would be utilized. This is same as what we had in 4G, we call it S10. But one of the questions that we have is that, okay, in this case, we can see that option 3X is also included. We can see, for example, this new radio is connected to EPC port as well. What is the requirement for that? This is that when we provide 5GC as the SA option, option 2, so maybe there would be some type of UE that they cannot support option 2, and there is just, for example, option 3X. And also they would use 5G at least for EMBB use cases for more throughput. So we just keep our NSA network for the option 3x. So non-standalone is there as well beside of a standalone. This is one of the cases that we have to take care about that. Okay, and at the end, at the right side, you can see option 4 or option 7 in order to remove your EPC and have your 5GC as the core for both 4G and 5G radios. It is optimistic, very good solution, but the case is that most of the UEs um, as of now cannot support this feature. It depends to the chipset providers and it is not provided yet. So what we can see in the 3GPP is just to use uh, the middle option B, the middle one, as combo node. So for example, same as what we had in 4G and 3G, we could have one gateway as the PGW and GGSM, for example. So as the combo node, we can have a mix of EPC and 5GC in all the vendors. It is what is recommended by 3GPP as the simplest option. Okay, that was fine. Please store all of your question. If there is, I would come back and discuss in detail with you. Okay, the next topic is about the network slicing. So this is one of the hot topics. So what is network slicing, how it works, why we have to do network slicing and in our network, what is the requirement exactly? So let's go through. Okay, let me start with this ITU IMT 2020 use cases and requirement. Maybe most of you are aware and informed about these requirements exactly in detail, but just as a summary, there are three type of major use cases. And the first one need to more throughput data rate in order to achieve more quality of service and quality of experience for the subscriber. So we call it EMBB. You can see on top of this triangle. The another one, what we had the same thing, we called it MBIoT in the 4G. So uh, this one just required the maximum number of subscriber in our network, for example, in one radio or more than one radio. So the connection density is so much important for the left hand of this triangle. And another one that we can say that in industry 4, it is more important that in other services. For example, we call it URLLC, ultra reliability and low latency communication. For this one, we can say that there are some kind of requirements such as minimum delay as the signaling and as the user plane part of the subscriber. So we have to just keep and reserve related resources to how to say, to just provide such a good service without any delay. For example, we can use it as the remote surgery. This is one of the topics, or self-driving, when one car would be automated and want to just drive automatically, needs many information about the traffic, about the streets, and about the environment near the car. So it should be so fast for the car to get this kind of information, process them, and just decide how to drive. As the detail I could provide about the performance requirement of each of these requirement type, EMBB, MMTC, and URLLC, you can see in these two tables what is the exact requirement for each topic. You can refer to the ITU IMT 2020 requirement and find all of these detailed requirements there and how to achieve them. Okay, as an example, for example, we will have network slicing for EMBB to provide more throughput. So assume that you will need two type of slices, one for the normal subscribers in your network, another one for the premium subscribers or enterprise customers, or even your MVNO. So you would have different slices and just use different resources for them. In this case, you will reserve and keep each resource, and you will how to say, achieve the safety in case of any resource utilization in your network. This is actually what we are thinking about the network slicing in the actual environment, I mean. So how to differentiate between the slices and how to address which slice should be used for which subscriber? There is one parameter in the 3GPP, we call it SNSS-AI, Single Network Slice Selection Instance Identifier. It could be provisioned in the UDM for each subscriber, and even UE can request for proper slice. UE can have multiple SNSS-AI at the same time, means that you can use multiple slices in your network at the same time, but it needs um, chipset development. Please take care about that. So maybe you are using some kind of chipset developer and vendor in your operator and your country that they cannot support this one. You can check it in detail with your UE team. Okay, how to design this SNSS AI to be used? There are two parts in the SNSS AI, SST and SD. SST is a slice service type. So as I mentioned, there are some kind of major requirements. So we divided it in the SST. We will have different SST for EMBB, URLLC, MMTC, or MIOT, and also V2X, which is added newly into the release 16 of 3GPP. Oh, and the next part is the service differentiator that is optional part of SNSS AI. We can use it for more different use cases. It's up to the operator, that's how many subscribers they have and how they want to address network slicing for them. Maybe some of the operators come that there is no any use case to use SD. So they would have just different slice, one for EMBB, another one for URLLC, and another one for MMTC, and it would be enough for them. But maybe some of the other operators, they want to divide their network to many more slices, and they want to reserve some kind of slice for their specific subscribers and customers. But the case is that how to design this slice identifier, how we should consider about the requirement, which kind of requirement should be considered. I just tried to listed some of these requirements that we can take care and design our slice differentiator in the operator. So for example, okay, this slice would be used for MNO use cases or MVNO use cases. So if subscriber is MNO or MVNO, different slices would be used. For example, for EMBB, we can have one slice for your own um, subscriber, or you can use another slice for your MVNO subscriber. If we want to use it for MNO subscriber, this is our B2B segment or B2C segment. So we can have different slices for this B2B and B2C. If this is our local subscriber, okay, sorry, if it is our own subscriber, so let's see, this is our outbound roamer, which is roam to other operator or country, or this is our local subscriber. So we can have um, a special slice for the outbound roaming, for example. For B2C cases or even B2B cases, what is the subscriber type? Some of the operator has a gold subscriber, silver subscriber, and normal subscriber. So you can have, for example, gold network slice, normal network slice, or silver network slice. or which kind of service or use cases we are going to provide. Maybe your operator want to provide different services and want to dedicate them to a specific network slices. Other some B2B customers, for example, they need something more than, for example, just simple B2B slice that would be shared. For example, you have a big customer in B2B, you don't want to use same slice with other B2B customers. So how to define this slice for that specific B2B customer? Okay, and just as a question to you guys, we discussed about how to define this network slicing in our network, but what should be the common and a specific network function for each slice? Which node can be used common for the all the slices, and which network function can be used for each slice? Please think about that. I would be happy if you have your answer at the end of this session. Okay, let's go to the final part. We wanted to just have a review, simple review about the multi-access edge computing in this part. So this is one of the hot topics that we are following in 5G. We have it in 4G as well. I just provide some kind of samples from operator, how they are thinking about the MEC. Of course, MEC is not a mandatory part of 5G solution or 4G solution. MEC has dedicated documents and references in ITU. It is defined by ITU. So in the MEC system, you will have MEC orchestrator, MEC platform, and on top of this MEC platform, you will provide your application and services. For example, multiple number of video on demand services would be installed in this MEC ecosystem as one sample. But there are some kind of different deployment types in the MEC. The first one, as you can see, is the UPF and MEC that is so much near to the radio, and after that, the other traffic should be how to say forward to the core network. The second option is to provide your put MEC UPF in the database. The third one is to use just a star solutions. Everything such as core network and even UPF and MEC would be connected to simple router that is connected to the radios. And the fourth option is to just connect your core network to all the radio, and after that forward related traffic to the MEC, and terminate other traffics to your anchor UPF, and send it to the internet, for example. But please consider that for all of these deployments options, and that is UPF that is connected to the radio. So MEC cannot be connected to radio directly. So there should be one UPF between the MEC and radio to just forward, to just, how to say, detect related traffic and forward it to the MEC. So thank you very much. I thought consume more time that I expected before. It was all from my side. Thank you very much. I would be happy if have your question as well.
Thank you very much, Mohammed, for this presentation. Thank you for your time. I know it's too late in Japan, so thank you again. If you we can start with the questions we have here in the chat. I think we have some questions here. Do you use filters like DK and STIUV for performance in containers? I think.
Which one?
It's the
can you repeat again? I didn't get the question exactly.
This is the first question by Musa. So do you use filters like deep?
Oh, yeah. I found it. I think this is SRIOV, not
Yeah,
STIOV.
yeah, yeah.
Yeah,
Yes.
yeah, 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 yeah. We are using DPDK, SRIOV. Such aspects are needed for more performance and due to packet processing and packet forwarding, and also SRIOV would be needed to just visualize the network functionalities. Yes, of course.
Second question is SCP used for signaling traffic, like sending traffic between microservices?
Exactly, exactly. As I mentioned, all the microservices, each of the microservices would be separated pods. So SCP will just interact with all the pods to manage the signaling traffic. What I say about the signaling traffic, this is just HTTP protocol. For example, if we have, how to say, one HTTP protocol between the SMF and AMF, we will go through the SCP. But if it is, for example, GTPU or some kind of internal traffic that we have between some of the pods, maybe we cannot use SCP. But for example, if AMF had some kind of pods internally and they are using HTTP and JSON-based application protocol, yeah, we can use SCP as well.
Yeah. The question is mine actually, because I'm more networking guy. So I saw in your slide a slide about Cisco solutions, and I was reading on Cisco blogs about Cisco solution on SDN and NAV that Rakuten has adopted, like NSO in the Mano layer and Cisco ACI in the NAV infrastructure layer for network virtualization. I don't know if you have more details about that.
What is the exact Cisco CI as the network visualization layer? Oh, okay, okay. Now we have RCP, Rakuten Cloud Platform, in our company. Okay, so all that we had as the ACI, okay, we can have on top of this RCP actually. Okay, but the case is that for the virtualization, okay, we will use this RCP actually, but for example, assume that we have multiple number of RDC, regional data centers, so we have to carry the traffic between these regional data centers. So for that one, we will use SDN or, for example, Cisco ACI beside of these virtualization platforms.
Okay, okay, okay.
Yeah.
Thank you. Another question is, what is the requirement to choose the right option? Is it 4G infrastructure? Usama, your question is not really clear. I don't know. What is the requirement to choose the right option? Is it 4G infrastructure? Usama?
About the first part, if Usama cannot speak now, about the first part, I can say that there are some kind of design that you should consider in order to just gather this kind of requirement. The first that is a UE capability. Okay, I can say that most of the UE providers, I can say chipset providers, same as the Qualcomm, they are just developing option 3X. So in this case, the other options would not be supported by them. This is one of the things that you have to take care. Another one is to check your network. In case of the radio, for example, for option 3X, your radio should support to connect to the NR and send related signaling to the EPC, and also your EPC, your HSS should be capable for this option. There are some kind of features that would be provided in the EPC and HSS as well. Even in the DNS, we have GNDNS, for example. There can be some additional options. For example, we call it NCNR to just choose a new PGW with more capacity of throughput for the 5G NSA subscribers.
Okay.
Yeah.
Another question is, Rakuten Cloud native platform is used. Is it used just for 5G, or also for other application like TV or e-commerce or all Rakuten business
I
outside of
got it.
yeah,
I got it.
telecom.
Everything.
Okay.
You can just compare it with, for example, Google Cloud Platform or Amazon Web Services, uh, plus operator level use cases. And this is just one simple cloud platform that provide the MNO services as well.
Okay. We can look at it as a CDN also, as a
Of
content
course,
delivery.
of
Okay.
course,
Okay.
of
Okay.
course, yeah.
Okay. Another question is, does the move to 5G require the full implementation of IPv6?
And I can say no, this is not mandatory, but of course it's better to use IPv6 because now we can see in 3GPP we are going to use SRv6. So this SRv6 would help us to have a smoother network through IPv6. It is not mandatory, but highly recommended.
Yeah. Yeah. Another question is, what would be the service type size for voice over NR? Or same question for video over NR.
Okay, for voice, you know, we have two type of providing voice in the 5G. The first one and easier one is EPS fallback. So whenever you have call, MCall or MO call, you will forward it to the EPC network. It is the first option, but for view NR that is not completed in the 3GPP, I can say that, or video NR, same situation. You can have a different slice. The slice type for the voice over NR or video NR is same as the EMBB.
Okay.
Yeah.
Another question. What are the transport KPI that are used to segmentize the path and locate the fault and optimize the 5G network?
What are the transport KPI are used to segmentize the path? Is it related to network slicing?
Zinedine, are you hearing me, Zinedine? Because you have asked the question, I think he may clarify more.
Okay, initially to answer to this question, I can say that I'm not how to say so much advanced in the transport part, but according to the end-to-end network slicing, there is some kind of aspects in the transport. I would refer to some kind of ZT white papers or even Cisco white papers for the transport as well, but it is not used as the SNSS AI that I talked through that. So there are another how to say differentiators and identifier to be used, for example, a specific route and a specific path for some specific slices.
Okay.
Yeah.
Another question is, SCP have some function with NRF?
Yes, of course. No. Have same function? Of course not. For the NRF, okay, you know, in the 4G, we had just some kind of minimum number of network functions. There were just MME, SGW, PGW, actually, and HSS, for example. Okay, so for the HSS, we could just write the IMSI range to the MME to find the HSS, or for SGW and PGW, we would use DNS internally to find the IP address of that how to say SGW and PGW. But in the 5G, we have many more network functions as I described them. Okay, all of them should be registered to the NRF. And during the network discovery for each subscriber related to their slice and other parameters, same as the SUPI of subscriber, or for example, the location of subscriber or DNN of subscriber, NRF would be used to provide the proper network function to the requester. This is the NRF functionality, but SCP is such a same as the DRA. For example, DRA would connect MME to the many number of HSS, or for example, connect PGW to the OCS or PCRF in case of diameter protocol. So we will have such aspect for SCP to handle the HTTP protocol. So for example, for NF registration to the NRF, AMF, UPF, SMF had to register themselves into the NRF to be selected in the future. So if we use SCP as well, they will send their registration message to the SCP, and SCP will forward it to the proper NRF. And even when you want to select one network function, this traffic goes to SCP, SCP forwarded to NRF, NRF forward response back to the SCP, and SCP forward this one to the source network function.
Okay, thank you. Another question is, Rakuten is the first cloud-native platform. My question is, how will 5G latency be lower if processing is being done in the cloud?
Good question. At first, I would.
Sorry. Thank you. First, thank you. This is my question, and if
yeah,
we get confused, I'm talking about more about the MEC challenges. For that reason, I asked this question. Thank
of
you.
Course. Okay. Okay. Initially, I would say that it is important that you take care this question for the playing part or signaling part. This is my first idea. And the second one is that, for example, for data plane, yes, you are correct. Because of visualization, will decrease the, how to say, the performance of packet processing and forwarding initially, yeah. But the case is that this aspect is open, and I can say all of the major vendors are working on that. For example, we are working with the most vendors, for example, Intel, okay, to just develop our network capacity in case of using better from the CPU cores and even our NIC or virtual NIC in how to say, in the better way. For example, I can say that initially most of the vendors, same as Cisco, Huawei, or even, for example, other vendors, and they had a minimum throughput. In case of this visualization, it could not be compared with their physical network functions, really. But I can see that after 1 year and 2 years, yeah, we can see even more capacity according to this visualization.
Okay.
If you have any question on top of that, you can raise.
There's another question. What about disadvantages of 5G network?
Wow.
Oh, we are ready to.
Disadvantages. I cannot see any disadvantage, but as of now, UE price would be more higher than the 4G because this is just new technology. So there is no huge, how to say, the manufacturer lines to provide the 5G capable UEs. And also for the operator, it is a huge cost to just develop their network to support 5G network. I don't see any other advantage initially.
Basically, it's an advantage to have the 4G.
Yeah.
Another question is, physically, how is the core network deployed? Centralized or decentralized? And what are the key equipment used?
For the first one, I can say that both of them would be possible, centralized and decentralized. For example, it's up to the operator. For example, in our company, we have more than 200 or 300 regional data centers, so it is easy for us to decentralize that. But the case is that which component should be decentralized. Mostly, I can say that the user plane part is important to be decentralized, same as the UPF. So we can just keep the other signaling, common signaling nodes, same as the AMF, SMF, UDM, in a centralized manner.
Okay. Um, uh, Another question is, according to your experience as a package engineer, is mastering the cloud infrastructure and IT aspects mandatory to work on 5G core, or to have an overview of cloud infrastructure and master the 5G core network functions, protocol, and signaling flows to work on it?
It depends on you, really. For example, both of these expertises is needed in one operator. The first one, I mean IT part, is how to onboard this virtual core on top of the virtualize and IT infrastructure. And they are two different expertises. For the first one, just overview in the cloud could help you to have a better understanding. For the second one, of course, detailed um, information and knowledge about the cloud platforms, how they work, which kind of feature is needed, how open source applications, same as what I reviewed it in my presentation, how they work and how we can utilize them in our network as well.
Okay.
I can say that it's up to you. If you are more happy to just focus on the 3GPP, okay, let's continue. But if the IT era and this infrastructure's scope are interesting for you, you can change your idea to just go through the cloud part as well.
Yeah, of course. Another question is, how 5G core provide UE position, location? Does it mandatory handled by LMF?
Okay. And okay, for this one, and it's up to the operator. LMF is not such a mandatory solution for the 5GC, but if you want to have this positioning and locationing of subscriber, LMF is one of the solution that you can use. But maybe you have some kind of, for example, GMLC solution in your network, so this GMLC cannot support HTTP protocol, SPI interfaces. So there are some kind of gateway between the AMF and your legacy GMLC, for example.
Yeah. What's the migration to 5G strategy? What is the migration strategy to 5G adopted by Rakuten? COPS on EPC or directly to 5G core SA standalone?
Okay, we have COPS on the EPC, so we will continue to provide 5GC beside of that.
Yeah. Still have a couple of questions here. For mixed deployment using both 4G and 5G networks, is it easy to connect microservices nodes to traditional hardware-based nodes?
Of course. I got the question. Of course, it is possible and easy. There are some kind of headaches and concern, but we have this kind of solution because, as I mentioned, there is some kind of cluster that you should um, develop this cluster for your containerized solution. But at the end, this cluster should be connected to traditional hardwares. Means that the traffic will goes through will goes from your cloud platform to your traditional hardware, but it is possible. For example, we have cluster gateway between the clusters, or we have ingress egress gateways on the right or left hand of the cluster to manage this kind of traffic as well.
Okay. What are the big or main challenges for an operator to deploy 5G? Challenges for an operator to deploy 5G.
I think there was another question in order to trace
Yes, that's a
control and
reply.
user plan.
Yeah,
Oh,
yeah,
really? Okay.
that is related to another question. I think he asked before the question that wasn't clear.
Okay.
Yeah.
So the next one is what are the big or main challenges for an operator to deploy 5G? And the biggest challenges is to select a vendor, really, I think. Because you know, we have many vendor that they are working in 5G, the open platform and open software. So most of the 4G vendors and even beside of them new vendors came to the 5G, but it's too much important to gather all of the services and requirement that you need, and according to that select your vendor, because there's many difference between the vendor and pros and cons, I can say. For example, some of the vendors are very good in the signaling part or in the subscription part, but they are not good in the packet performance of the UPA, for example.
Yeah. Yeah, we have a couple of questions here, and after that we will finish. I think.
Okay, that's fine.
I have one question. Sorry.
Yeah.
As we know, in the 5G, everything will be quick. There will be a lot of data generated and energy used and consumption. So my question is more like regarding programmation now. I mean, to reduce, for example, the energy consumption, can we consider machine learning to optimize it?
Of course,
Considering
yeah,
requires
yes, of course. This can be not mandatory, but recommended part of your platform as well.
Okay, thank you.
Okay. So, another question is, where will MAC be located? Location with 5G core or separated area that is near the 5G NR location?
And near to the 5G NR location. This is the concept of MEC, to just put the how to say the services nearest to the subscriber. For example, there is one video on demand or some VR AR use cases. So instead of putting, for example, NR in one city and have the database or service in another city, let's provide a MEC solution beside the NR and just keep this kind of services in your MEC platform.
Yeah. Okay, we have like 3 questions, I think, or 4, and we will finish, I think, because it's
Okay,
too
fine.
late.
No problem.
Okay,
We
thank
can
you.
continue with 15 minutes.
15?
Yes, let's do it.
Okay, thank you. So, guys, you can share your questions for you. We have for 14 minutes, 15 minutes. Is there now a 6G network, and what is the challenge of 5G project?
For first question, no, there is no 6G network, you know. We can see just some kind of white papers to the NR part or maybe to the processing part, same as machine learning and some other else. But 6G network will be how to say designed whenever related requirement will be provided from the ITU. So I think for this one we should wait for maybe 5 or 6 years later to IMT 2030 will be generated by ITU. So after that 60 network would be designed by 3GPP. And for the second question, what is the challenge for 5G project? I think I answered this one before.
No. What are the mandatory network equipment to implement 5G network? Can we ignore some of them?
Yes, it depends to your design, and also it depends to the vendor capabilities. Okay, for example, NSSF, it's what we use in network slicing. It is not mandatory in some kind of solution. So some of the operator can skip this one. Also, we have unstructured distributed database, UDSF, for example, from release 16. This is not mandatory. For example, we can use some kind of virtualized databases in our network instead of the AUSF. And also we have in not mandatory for man SMS for